So with that, that's all the things I can think of right now, unless there are questions, requests. So let me play with the class GPT, or continue alpha testing our custom GPT. And I think last time I worked with this was when we were wrapping up electrostatics, I think, before the timed assessment demos, I think. So so I think since then I've updated it, and when I was updating, I had two main goals. One, get it to solve multi-part questions, one part at a time. And I think based on my testing with the physics 4A, I think it's done that fine. But other parts I wasn't quite as successful. It's still giving you too much help all right away, and I don't know fixing that how easy it'll be. And I've noticed one other issue with my other class as I was, alpha testing. It doesn't draw diagrams very well. So yeah, oh right, this is last week's, so that's right. Let me redeem. Do I want to redeem late passes? Let me just open it in practice mode. And actually, this is a time in the semester where there's no big difference between doing it properly and the practice mode. I guess the only people for whom this could matter is if you finish the meeting on the first track, and but you fell a little bit behind, then do use the late pass and do the actual attempt. But otherwise, I can bring a practice mode attempt during our required one-on-one meeting. So practice, not a practice, no difference. So let me do some circuit questions here. Here I think I'm just gonna ask it a couple. They are all, in my view, I think all easy questions. So so let me ask this. Let me ask this way. So I can play the role of confused student. I mean, that's the role I always play with this alpha testing, but the specific role I'm playing is a confused student who listens to me, but only sometimes. So I will say, I'm not sure how to approach this question. I would have done it using, I equals dq over dt, but I remember the professor saying he doesn't use that formula. How do I answer this question? And if you actually listen to everything I say, I was saying this in the context of when you are, not using this formula, in the context of discretion of current flowing through a wire, then dqdt is not well defined because Q as an expression is not well defined. But in this context with the capacitor, that's the one context where you actually do use it, because the Q is the charge stored on the capacitor. It's got a well defined function. So yeah, of course you take the derivative of it. Like, yeah, use it. There's no other way to do it. For B, yeah, correct. The course doesn't, because right, it's got my lecture notes, so I think it knows my own explanation of why I don't do it that way. I conceptually do it this way. Yeah, that's the reason. See a question about current used by whether it's constant, steady. I never say this. This is Ohm's law question, but you have to first confirm that it's an Ohm's law question. So I think it's hallucinating, something that I wouldn't say. If it's but capacitor charging, great, you can do that. So here, even though we are a little bit away from lecture 24, I'm actually processing the transcript for these right now, and next time I update the CoA physics GPT, I'll actually be including that content. Even though we are nowhere near dealing with the capacitors, in this question, the question actually gave you a lot of info. It gave you the charge as a function of time, so you can take the derivative. So what the actual question says, sorry, I thought you could read the image. Let me paste it again let me know if you need me to type out the question still, and I'll paste. I think there might be some bug where the first image I paste, it ignores or can't tell, or I don't know. It's been doing this where it's got an image and then it still asks me to do this. It might be maybe something introduced through the prompt. So it's not without I equals DQDT. You use I equals DQDT, but with the understanding that this is the correct context. Model part A. Yeah. This is a side effect of some of the prompts system instructions it has. It's a single part question, but I gotta work on making it behave more kind of less stilted way, maybe. Your turn. Take the derivative. So I'll say, so here I do take a derivative because it involves similar, and the answer is yes. So when you take the derivative, so I can make a mistake. I can make two mistakes. I misremember the formula for the derivative of cosine, so I forgot the minus sign, and I forget the chain rule. So I don't multiply by omega. Yeah. Okay. So I'll say, okay, I took the derivative, but it says my answer is wrong. Can you tell me why? Okay, I took the derivative, but it says my answer is wrong. Can you tell me why? I wonder if it'll catch both mistakes. I might be confusing it with multiple things at a time. We'll see. If assuming it answers well, that's really one, I think, advantage of generative AI, because it can read sometimes it can read your response and actually respond to what you've done. Now, if it's just telling you the right answer, then I have a homework helper videos. And yeah, I did notice that. So Azure. Oh wait, never mind. It got both. Missed the chain rule and the sign. Yeah. And then I don't know. So if I could have, if I could micromanage CoA physics every time it responds to you, I would have actually have it stop here. So once it's given you what your mistake was, then it should really give you the chance to fix it, and then then you fix it. Then it should not tell you that that's correct. I'm sure this is my question. That's why I wrote that side note. IT is most positive, I think, when the cosine term is -1, right? By the way, I got the question right. Thank you. So yeah, so I got still some things to work on. I don't know if it's necessarily doable. I might have to play with the ChatGPT's own learn and study mode to maybe get get some sense of how to get it to be more interactive. I don't know. Let me just pick one more question. I again think all of them are. Let me get a question that involves Ohm's law, but not this one, because this one's too easy. Let's see. Oh, you know what? This might be a good question to check if it. So even though it was saying this, where is it? Part A only. Like sometimes it says that and then moves on, because it's AI. It's not actually thinking. It's got bugs in it. Let me try asking this, and let's see how well it does in stopping after just part A. Let's move on to my next question. This one mentions resistance, so I have to use Ohm's law here, right? And I think, again, if I could micromanage ChatGPT, CoA Physics GPT, what I would want you to say is, answer your question first, yes, and then maybe stop there, or invite yes. If you want to try out the question, would you try that? And let me know if you get stuck somewhere. Like that's what it should do, but I don't think it's gonna do that. Cover then, yeah. But I think these are the right lecture videos. You don't need the Kirchhoff's rules here quite yet. Treat the batteries. Yeah, it's giving you all these steps, which. It should have let you figure it out first, but let's say we are following this step. Radio acts as an external resistor, same current flows both, series connection, Ohm's law and the loop rule to find. I mean, you don't need the loop rule if you know if you know how to add resistors. If you know how to add resistors in series, you can just do that. And in fact, that's what I'm gonna do. Voltage on the radio is. Yeah, I don't know. So this portion doesn't come from me. I avoid the letter E for the voltage source because that's associated with the EMF, which I avoid. So that doesn't come from me. But I don't think I can train it away from using the term EMF because it's a fairly standard term. Minus IR, internal resistance, voltage supply to the... Yeah, so it's given me all the answer. Yeah, and supposedly this is only for part A. Yeah. So, can I do this in my head? I don't think I can do this in my head. So let me do it with a calculator. I guess I should find the current separately. Yeah, or I guess... let me do the compact form since I'm using the formula it's given me. So the compact form is the voltage, open circuit voltage. Is it NiCad cell? NiCad cell has 1.25 open circuit. Okay, 1.25 times the resistance of the radio, 3.2 divided by the sum of the resistance of the radio and the internal thing. Oh, that's 3.24. So that should give me and so I have to say equals 1.235. 1.235. It'll say it's correct. And let's say we continue with the alkaline cell. Okay. So I hear you. I don't think it's once you've done that correctly, I don't think it's realistic to get stuck on the next question. So let's just do that. So it's 1.58 times 3.2 divided by 3.2 plus 0.2, so 3.4. So equals 1.487. 1.487. Okay, correct. Radius effective lowered when its volume turned up. The volume, what value of radius resistance, the greater voltage. Oh, so I think here I can imagine someone getting stuck. I got 1.235 for part A, and I used the same formula to get it correct, but C looks complicated. Can you give me some help? But not all the answers. I need to learn how to do this myself. Otherwise, I think it's gonna just give me all the answers. Can you give me some help on setting up the problem for part C? And I don't think I need to paste again. Although, let me, I don't think I need to paste again because it already has part C, so you should be able to refer back from earlier image to know what part C is, ideally. And need to think of the system prompt where, because I think when you directly give it this instruction, then it's pretty decent about not giving you all the answers. At least that's what I remember last semester. But to accomplish that in system prompt has been hard. Okay, let's tackle C. Terminal voltage is equal in the model. So I think it should have just stopped here. Like some of you, like with that, you should, or maybe not. That's eval voltage. No, yeah, I like with that equal threshold, because maybe you got confused by the word greater and didn't realize that there's a condition that you can use to set up an equation. Now I think this is too much because it's given you all the steps, like you set it up, and then so threshold R satisfies. So cancel R not equals 0. Yeah, so cancel that and that. Cross multiply. I'll just tell you, I hate that phrase. I've heard some of you say that phrase. I just don't like it, and I think it's just me being. It's more of my personal preference thing, which is different from EMF. I think EMF is a terrible terminology, and I'm not the only one who thinks that. But cross multiply, I don't know. I just think people misuse it sometimes. But I'm not going to cross multiply, but what I am going to do is I'm going to set the denominators equal to each other, because that's really what the condition amounts to. So you say R plus R nickel whatever is equal to R plus R wait, that's not right. I still have to retain these voltages. That's what made it complicated. So then I'm imagining I did the reciprocal, so it'll be divided by I'm just gonna change this to V because I'm not using the word EMF. Vn divided by V alkali. Get a single equation for R, plug numbers in. Yeah, let me pretend that I'm stuck. So let's say I did cross multiplying, and so if I did that, what I would get is here cancel this, and if we alkaline here, if we NiCad here, and let's say you even got as far as this. You distributed it, and you got we alkaline R plus Rn, we alkaline is equal to we NiCad R plus R alkaline times no room. Let me just I think the thing to do was to move this the whole thing a little bit to the left. Say plus R alkaline times V NiCad. So if someone's struggling with the algebra, then this is where it should have told you to collect the like terms in R. I got this far in algebra, but can you help me with the next step for solving for R? Because I do see from time to time a lot of people plugging in numbers, and then maybe that gives you a better sense of what to do. As a crutch, it's fine, but as you go to higher levels, you should learn how to do the symbolic algebra. And this is where I do believe generative AI can be helpful, because it can see what you have done so far and respond in real time what the next step is. I'm sure I worked this out in detail in my homework help video, but maybe some of my first few steps are not the exact same steps you are doing. So let's start from your correct relation. Good. Distribute both sides. I did distribute both sides. What do I say? Yeah, collect R terms on one side. Yeah, so these are the correct algebra steps. Yeah, and you plug in numbers there. So let me do that, and then we'll move on to the magnetism questions. So again, so here, I wish it would just give you this hint and then stop there. And then like after this, say the next steps are factoring and then dividing by the other term and not give you this right away. I don't know how to stop it from doing that. All the system instructions I try, they all seem to have a more side effects than the the desired effect. So NiCad voltage 1.25 times the alkaline internal resistance, I think I had the 0.2 minus the alkaline voltage 1.58 times the NiCad internal resistance 0.04, that's the whole numerator, divided by 1.58 minus 1.25. So that should give me 0.566. Probably, I think. Yeah, felt right. So I'll say, okay, I got it, thank you. Okay, I got it. Thank you. I have some magnetism questions from the next problem set. And then I'll get to that. So let me mark this as done because I have to do that anyway. And I'm gonna go to the link for the problem set. Oh, wait. I haven't done problem set 8 either. So let me do problem set 8 first, and then maybe one could, yeah. So let me spread those out. I need to do problems, so it's gonna be 7, 8, and 9. Yeah, I think that actually feels right. I've skipped this portion of the session for a few weeks because I had things to do. I think 2 weeks ago it was the timed assessment that I was doing, and electrostatics timed assessment, and last week it was just finishing up all the homework helper video for the intro to magnetism problem set, and now what I think that's beginning to feel correct. So let me do that. So yeah, I do have to clear this, so let me do that anyway, and I'll do problem set 8. And I guess problem set 8, I could just use late pass. Like I'm not prevented from using late pass, but at this point there's no big difference between attempts with the late pass and the practice mode attempts. Either way, really what you're doing in this written work is practice. It's practice for the required one-on-one meeting. So whether it's labeled as practice mode or not. So here, let me So I'm just interested in how well ChatGPT 5 answers these questions, because it's always a struggle with the magnetism. I think because it involves a geometric reasoning. So I'm gonna ask this question, and I'll say, I got these 6 situations. I'm really struggling with the right-hand rule. Can you help me? So I'll just paste these in one at a time. So 6 situations, A through F. I got these 6 situations, A through F. To find the direction of magnetic force, and I know I have to use the right hand rule, but I've been really struggling with that. Can you help? So one, let's see if it helps in an actual helpful way, and 2, if it gets them correctly, because in the past it hasn't gotten everything correctly. Governing equation, yeah, cross product you're doing. Did it give the? Let's see if we understood each case correctly. So A, V is down, B is out of page. Great. B, V is up, B is to the right, good. C, V is right, okay, good. B is into the page, D, V is to the left, B is to the right, good. E, V is into the page, B is up, good. F, V is out of page, B is to the left, good. F, so the cross product, let's see. I think it's given you too much information again, but that I can't really stop yet. I gotta try different things. I wish it gave you a couple examples and then had you can you try the rest? But let me just try. So reasoning, fingers down, curl out of page. So F is to the curl out of page, down out of page, to the left. Let me just do it. So it gave you the correct steps. Fingers down, curl out of page, out of screen from your perspective, and thumb point from your perspective to the left, not right. So so A, if I simply enter this, it's gonna be wrong. But let's keep going. Up, right, so up, and then right. So into the screen from your perspective. And I'm not crazy. It's just getting it reversed, right? Let me just answer what it's giving me, and then let's see, and then right into the page, up, and am I somehow mixing it up? Let me just answer what it's giving me, and I think it's just gonna be all exactly reversed except for this, because D is 0 is correct. Because they are anti-parallel. So for E, so it's into the page, up. So that should be okay. This should be to the right, and I think that is right. Yeah. I was hoping you would just miss everything. Then you just exactly reverse it. It's not working out that way. So out of page, left. So that's down, up. Yeah. So I think it's still struggling because I answered the way it's given me all the answers, and I think it's got basically one right. Yeah. Or sorry, including that too. Yeah. So I only got 2 right, or I'll say we only got 2 right. Are you sure you're applying the right hand rule correctly? When I follow your direction for A, that is what you say here, fingers down, curl out of page. So fingers down, curl out of page. My thumb points to the left. My thumb points to the left. At least if I use my right hand. Am I supposed to do this with my left hand? Actually, they are both questions. No, question statement. I mean, it's called right hand rule. You're not supposed to use your left hand. Left. Okay, is it gonna get it right the second time? Maybe. Left into the page. Up. That is interesting. It missed it the first time, but I think it reversed everything. So in the process, I mean, it improved, but not perfect, because the E, it shouldn't be left. The right was correct. So let me ask. Okay, it's looking better, but E should have been left as right, right? Should have let me just should have remained as right, correct? I'm pretty sure actually large language models are good at dealing with the kind of linguistic ambiguity. So I'm pretty sure it would have handled it correctly, but yeah. This is a joke. People, who code with the generative AI as like a coding partner, they say they get tired of this. Like, get it right the first time. Like, getting tired of hearing this. Reanalyze. Okay, let's see. Left into the page up to. Well, yeah, third time's charm. I think it's got everything right this time. Yeah. Yeah, good. Yeah. Well, let me move on. Let me ask it. Is there one other better question? I don't have a lot of time, so let's actually move on to the next set. So I was thinking about asking these, but I have had a ChatGPT 5 answer these pretty well when I was testing out these questions while I was programming it. So I think it's gonna do fine. So I think this is good for for problem set 8. Let me just pick one question from problem set 9 and do that and wrap up this session. So I think let me do it that way. So I think I cleared most of the stuff. Need to clear that. And then now we should be at this week's material, problem set 9. Yeah. So here I'll say that's good. I got lots of questions to catch up on, and let me ask this one. Let me see if it correctly gets that this is a Biot-Savart's law question, and also how much hint it gives. If I'm guessing right, it'll probably give me too much of the solution all at once, or hopefully just the part A, but still. That's okay. I have a lot of questions to catch up on. 3 weeks worth. I have this question from the next problem set dealing with the sources of magnetic fields, and I'm stuck on this. I tried doing something similar as what the professor did in his application of Ampere's law question, but I feel so lost. And it should tell me, oh, you don't use Ampere's law here, you use Biot-Savart's law. When the question itself is written in a way where you can't use Ampere's law, because it's having you deal with a tiny segment of the wire. So actually using Biot-Savart's law, it's almost trivially easy, because you don't actually have to do the integral. You just deal with the integral and the portion. Sure, ChatGPT is gonna give me this, but you just deal with the infinitesimal contribution to magnetic field is 4 pi k over c squared. I think that's correct. Or no 4 pi. No, it's k over c squared times I cross dl. So I cross dl, where these are treated as vectors, divided by r squared. Like, you just use that. You don't have to do any integrals. And here dl would be that 0.8 millimeter segment of wire. Yeah, I'm pretty sure this coefficient is correct when you substitute to use Coulomb's constant. Treat as a stress wire. Yeah, Biot-Savart's over a small segment. yeah, it's a cross product. When you're looking for magnitude, it'll give you the sine theta. Sorry, I thought the coefficient there was in terms of Coulomb constant NC, isn't that right? Let me see if it actually pulls the correct info from the lecture notes. In the lecture notes somewhere, I should basically give you both. One that uses this combination because it kind of makes you think about speed of light, and the one that ChatGPT gave, that is actually the more standard one. That's what most textbooks will be using at this point. But I'm trying to keep Coulomb's constant alive and kind of hint at something that's coming in the future. Oh, maybe it's not. Yeah, but it's misunderstanding, so it doesn't quite. Yeah. So it's not. Yeah. I don't know if it's. Well, it's something for me to think about. I don't know if there's a good way for me to make sure. Yes. So I'll just ask this question. Sorry. Can you get the details from the lecture notes? The instructor did say this is something non-standard that is doing, and there might be more info in the lecture. This is already, kind of line of question that most of you wouldn't be engaging in. I don't know. I don't want to give us the GPT too many micromanaging rules. I've done that once for standard strategy, and yeah, that's the correct. So I did remember it correctly. Good. Yeah. Yeah. So. Yeah, that's fine. Yeah, that's exactly what the connection is. So, I think from what it's telling you, there should be enough for answer here. Part B. Oh, I guess yeah. It's not asking for the direction. Yeah, in fact, the direction would still be kind of perpendicular to the page. So I think all of that content is good. So I'm just gonna let it be and see if there's one more question I can ask, and we'll wrap up this session. Because that's Beer-Savage's law. There might be maybe an Ampere's law question. Or this could be interesting, because someone might think I thought current parallel in the same direction. Someone might think, oh, pushes the wires apart, but it's the other answer that's actually correct. If I don't have anything better to use, I'll come back to this. Maybe this is better. I'm not sure. Yeah, let me do question 6. I think question 6 is at least I can make a mistake that I think is I don't know, slightly more plausible. So here, what someone I can imagine someone doing is maybe after some looking up and whatnot, answer here. So 3 mu naught I. And then I think A should be right that way, and then kind of continue on with that for the rest. So path B, you say 4 mu naught I, and that'll be wrong. And path C, you say 1, 2, 3, 4, 5, 6, 7, 7 mu naught I, and D 2 mu naught I, and I think I'll get one additional one correct. So I'm just doing from memory. I think this is graded as correct. Let's see. Yeah. So this is my question to you. To the GPT. Okay. Okay. Thank you. I have another question, and this time I think this one has me using Ampere's law, unless the mathematical expressions look really similar to what I see in Ampere's law. I got only half the questions correctly. Can you help me understand why the half I got wrong are wrong? I can't figure. It's a matter of, I don't know, attention to detail, or understanding the sense of direction when you're dealing with a kind of flow of current through a surface in a way that's consistent with the line integral around the open surface, where the line is chosen by the boundary of the open surface. Let's see how well CoA physics of GPT explains this. So here, I don't think I would mind the detail of explanation. Like here, I've tried it, and I don't think there's a way to answer this inquiry well without basically giving you all the answers. So there, I think it's fine if it gives you all the answers, because here it's not revealing too much right away. It's responding to someone who's tried a question, got stuff. For B, it has to tell me to pay attention to the direction of current. For D, it basically has to explain why the sense of direction for C and sense of direction for D are different. It has to the direction of the loop that you pick. Well, wait for its answer. I wonder how it'll explain C and D. I thought B was easier. You can kind of see, these two opposite directions, same amount, they cancel each other out. Like I can imagine someone guessing with their way there. Here is, I think, a lot harder unless you correctly remember the convention involving right hand. So that's where I'm interested in seeing how does CoA physics of GPT explain that for C it's a positive, and for D it's negative. Okay, almost there. It says 48 seconds, but it felt longer than 48 seconds. And while it's answering, oh wait, my screen's not frozen. I thought it would have frozen. Sometimes it freezes. Although I think something, I'm clicking and dragging it. Yeah. I'll just wait. I could open a new tab, but I think by the time when it's finishing answering, the screen kind of starts working anyway. Although here maybe it's not. Let me duplicate it and see. I just want to make sure the connection didn't cut out or something. Okay. I'm not sure why it's stuck here, but here I have the full thing. Let's see, classic Ampere's law. Yeah. I'm not sure if it is lecture 21. Let's just double check. Sorry, I'm just curious. Is it? I think that is actually a solved the problem. I think it stopped hallucinating lecture. Nope, it is still hallucinating. It's not lecture 21, it's lecture 20. Lecture 21 it's the exam review lecture. So yeah, it's still hallucinating lectures a little bit. Only the lookings of form and compute algebraically how to assign sign. Yeah, that's the part that I need explanation of. That out of wait. follow the arrows on the dashed path. Curl your right hand fingers along that direction. So for A, you can say, okay, right fingers curl in the counterclockwise direction, and the thumb points out. So if the thumb points out, then current out of page is plus I. Yeah, that's great. And minus I if the thumb points in. I see, I see. So let's say we are looking at crosses, currents into the page. Then it's saying it's a plus I if the thumb points in. So with a C, you curl your fingers in the clockwise direction. Then the thumb points into the screen, viewed from your perspective. Then thumb points in, so plus I. That explains the C. And minus I, so with the D, the loop is going counterclockwise again. Thumb points out, so it should be minus I. Yeah, I think that's right. Equal, yeah. So that's a great explanation, I think. So this should be minus. Why is it saying 3? Only 3 turns. I think I miscounted. So I'll say thank you. I think for there are only 2 turns included in that loop. I think I understood your descriptions about the directions, but I'm not sure how to orient my hand for that. I mean, like sometimes my hands are like in a weird direction. Maybe it doesn't feel natural to you, so you can't quite get your hand in the right direction. For that, can you show me an image or something of applying those rules? Just testing it. I don't think it's gonna give you a correct image. Yeah, I understand the directions. I don't need to see your hand. Can you show me an image of hand model following those directions? It might say no. And I guess what I'm trying to see is if it complies and actually gives an image, I want to see if it looks correct. I think it's gonna look incorrect because image generation, it goes through DALL-E, and so far DALL-E hasn't generated correct pictures for anything, at least the most of the time. So, in fact, that's one of the things I need to work on when I update the GPT this weekend. I need to tell it to use not image generation but plot generation whenever possible for things like a free body diagram and other like line drawings. I gotta figure out how to get it to always do it that way in system instructions. Here, once it finishes generating the image, if I had to bet, my bet is the image is wrong, or it's possible it's not even relevant to the actual inquiry, because I want to see hand, and yeah, it's like you can see thumb is pointing that way, and it's like, what is that? Like that's that's not how you're applying right hand rule. Now, some of you might be using the 3-finger version, so that one doesn't really neatly apply to Ampere's law. That's why I prefer the whole hand version. It naturally morphs into the kind of descriptions that's here. These are all curling fingers. That's the whole hand version. Those kind of morph naturally between different versions. But yeah, drawing, that's the one thing that ChatGPT still can't quite do. It'll generate an image, but that image will not have any it doesn't correspond to anything correct physically. So I don't know. I think it's almost an architectural issue. I don't know if they can, something like an image of a hand, I don't know if it can ever be done correctly. Because things like free body diagram is sort of line drawings. I can imagine there being a different algorithmic pathway that does it correctly. But like drawing of a hand, I think that still needs a human being, human artist to draw it correctly. So, anyways, I think that's all the time we have. Thank you so much. Those of you who are joining here in real time and those who may be joining by recorded video, I'm gonna call the session to an end here. Let me say goodbye to people joining by recorded video, by which I mean I'm gonna start the recording, and I'll stay online briefly in case people here in real time had any questions. So bye to people joining by recorded video.